Our last section in Chapter 11 is Section 11.6, Surface Area and Volume of Spheres. A sphere is a set of points in space at a certain distance, the radius, from a point, which is the center. The sphere's surface area is 4 pi times the radius squared. And here's our radius in our sphere. Number 1 says how much plastic is needed to make a beach ball with radius of 20 centimeters. So we're looking for the surface area. So surface area is equal to 4 pi times our radius squared. So surface area equals 4 pi times 400, or 1600 pi centimeters squared. And if I wanted to round that to the nearest tenth, that'd be about 5,026.5 centimeters squared. Number 2 says round beads 1 centimeter in diameter are to be gilded with a thin layer of gold. If 1 container of gold will cover 100 centimeters squared of surface with the desired thickness, how many beads can be covered with 1 container of gold? Alright, so they told us that they're 1 centimeter in diameter, which means the radius is half a centimeter. So let's first find the surface area for one of the beads. So we're going to take 4 pi times our radius squared. So surface area equals 4 pi times 0.25. Or about 1.0 pi centimeters squared. Then to find out how many beads we'll be able to cover, we'll take how much the gold covers, so 100 centimeters squared, and divide by 1 pi centimeters squared. Now, rounding to nearest tenth, we get 31.8. However, in this situation, we have to round down to 31 beads because we do not have enough to cover 32. So 1 container of gold will cover about 31 beads. Number 3 says 2 congruent figure 8 pieces of cowhide are used to cover a baseball. The diameter is about 2.9 inches. What is the area of one cover? Alright, so if our diameter is 2.9, then our radius is 1.45 inches. So let's find the surface area of the baseball. So that will be 4 pi times radius squared, so 1.45 squared. So our surface area equals 4 pi times 2.1025, which is 8.41 pi inches squared, and rounding that to nearest tenth, it's about 26.4 inches squared. So that's the surface area of the baseball. If we wanted to know how much one piece of cowhide would cover, then we would take our total surface area, so the 26.4 inches squared, and just cut that in half, since they're 2 congruent pieces. And we would get that each piece covers about 13.2 inches squared. The sphere's volume is found by 4/3 pi times the radius cubed. Again, radius of our sphere is from the center to the edge of the circle. In number 4, we want to find the volume of a sphere with a radius of 12 feet. So here's our radius. So volume of a sphere is 4/3 times pi times radius cubed, so 12 to the third. So volume equals 4/3 pi times 1,728, which is 2,304 pi feet cubed. And then if we want to round to nearest tenth, that's about 7,238.2 feet cubed. So we can either leave our answer in terms of pi or round to nearest tenth. In number 5, it says a standard bowling ball cannot be more than 27 inches in circumference. What is the maximum volume of such a ball to the nearest cubic inch before the holes are drilled? So remember, our circumference is equal to 2 times pi times the radius. So we first need to find our radius, and then we can find volume of the bowling ball. So our circumference is 27. That's equal to 2 pi r. So if we divide both sides by 2 pi, we get that 4.3 inches is our radius. So then volume of a sphere, 4/3 pi times the radius cubed. So volume equals 4/3 pi times 79.507, which is 106.01 pi inches cubed. And we want to round that to the nearest cubic inch, so we'll multiply by pi and round to the nearest whole number. We get 333 inches cubed. That's the maximum volume for the bowling ball. Number 6 says racquetballs come two to a can. The can is a cylinder and the balls are spheres. If the diameter of the can is 6 inches, what is the largest possible volume of the racquetball? Alright, so here we're given diameter at 6 inches, so then that means our radius is 3 inches. So using our formula for volume of a sphere, we'll have 4/3 times pi times our radius cubed. So volume equals 4/3 pi times 27, or 36 pi inches cubed. Now that would be a sphere that could fit in the can. Keeping in mind it says that there's 2 racquetballs in a can. Then we're going to divide that number in half. So for each racquetball, we'll take 36 pi divided by 2. So we'll get 18 pi inches cubed, which is about 56.5 inches cubed for each racquetball. In our last example, number 7, it says Ursula made a spherical cheese ball for a party. She formed it from a block of cheese 8 centimeters by 8 centimeters by 20 centimeters. What is the diameter of the cheese ball? Alright, so since she started with a block of cheese, we first need to find the volume for the block. So for the block of cheese, so we're talking about a prism here, so volume is going to be capital B times height. So volume will equal 8 times 8 times 20, or 1,280 centimeters cubed. So that's the volume of the cheese. Then we can find out what the diameter is. So taking our volume for a sphere, 4/3 pi times radius cubed. Oops. So our volume is 1,280. That's equal to 4/3 pi times radius cubed. Then solving for radius, so we're going to multiply both sides by 3/4. Get rid of that fraction. We have 960 equals pi times our radius cubed. So then we have to divide both sides by pi. We get about 305.58 as our radius cubed. Then to solve for r, we need to take the cubed root of 305.58 as opposed to just taking the square root. So if you take the cubed root of that on your calculator, you get that the radius is about 6.74 centimeters. And then the directions, it asks for the diameter, so we just need to double that. So to find diameter, we'll take 2 times 6.74. So our diameter is about 13.48 centimeters, which we could round and say that's about 13.5 centimeters for that block of cheese.